Hello, everyone. So, now what we're going to be doing is seeing, honestly, quite an interesting property of these imaginary values. Um, and kind of seeing a certain pattern that emerges when we deal with them. So, it asks us to simplify each of the following. We have I to the third, I to the fourth, I to the fifth, I to the sixth, I to the 10th, I to the 100th, I to the 100 or 1007, and I to the negative 2312. Okay? This is just gonna be using our exponent rules. So, let's start with some of the most basic foundation, right? I to the first power we know is the square root of negative 1. I to the second power, well, we know that that is just the square root of negative 1 squared, which is just negative 1. Now, how about I to the third? Well, we could also just define that as using like exponent rules. We can split this up as I times I squared. Now, I, we know, is the square root of negative 1. And I squared we already established is negative 1. So, multiplying this together, negative 1 times the square root of negative 1 is negative square root of negative 1. A little weird, but okay. So this is negative square root of negative 1. We could also think of this as just negative I, because we could just simplify this as I, but we would have to leave the negative in the front. So how about I to the fourth? Well, that can be split up as I squared times I squared, which is, I should have really put the exponents on the outside. Let's do that. I squared times I squared, which would become negative 1 times negative 1, which would become a positive 1. So this becomes positive 1. Interesting. Okay. I to the fifth is the same thing as I times I to the fourth, which is I is the square root of negative 1. And I to the fourth we established is 1. And anything times 1 is just itself. So that's the square root of negative 1. Square root of negative 1. Or just I again. Because that's how I is defined, as the square root of negative 1. And I to the 6, maybe we can see where this is going to go. I to the 6th power is the same thing as I to the 5th power times I. And I to the 5th power, well, we know that that is just I. So we have I times I again, which is I squared, which we know is negative 1. So this is negative 1. Okay. And also the same thing as I squared. Maybe we should note that. So it seems we have a repeating pattern. It goes, this is just I. It goes from I to negative 1 to, this is negative I, then to positive 1, then to I again, then to negative 1. If we were to do like I to the 7, well, that's just I to the 6 times I, and I to the 6 is negative 1, times I gets us negative I, which is also the same thing as I to the 3rd. Okay, so we can see the pattern is just repeating over and over and over again. I, negative 1, negative I, positive 1. I, negative 1, negative I. And then I can pretty much guarantee I to the 8th power is I to the 4th times I to the 4th, which is, well, I to the 4th is just 1. So it's 1 times 1, which is just 1. So it goes, again, repeats the pattern. So it seems like every 4 cycles, or every 4 terms, it repeats a cycle. So the powers of I are just going to constantly repeat in groups of 4. So how about I to the 10th? Without doing much work, how can I figure out what that is? I to the 10th. I mean, that's just I to the 8th times I squared. And I to the 8th is 1. I squared is negative 1. So it just simplifies to negative 1. That's pretty easy. So, continuing onward, how about I to the 100th? Now, I to the 100th, well, 100, the easiest numbers to work with are like 1, right? Or negative 1. Those are really easy to work with. I know I to the 4 is the same as 1. And 100 is divisible by 4. So I can rewrite I to the 100 as I to the 4th to the 25th power. Because if we remember, the rule was we would have to multiply it back in, and 4 times 25 is 100. And that just becomes, well, I to the 4th again is 1. So it's 1 to the 25th power, which is just 1. Now we have I to the 1007th power. Now again, I like multiples of 4 because that lets me simplify it to a 1. So I can break this down, this 1007, as to get it to a multiple of 4, the closest one would be I to the 1004th. And to make up the difference, it would have to be I to the 3rd multiplied with it. Now that becomes, well, since 1004 is divisible with 4, we can rewrite this as I to the 4th raised to the 251st power. And we can rewrite I to the 3rd, we know, is I to the 3rd is the same thing as negative I. So I can simplify that as well. And of course, I to the 4th is 1 to the 251st power times negative I, 1 to any power is just going to be 1. And 1 times negative I is just negative I. So this establishes that I to the 2007th power is equal to negative I. Now for the last one, we have a negative exponent. Oh my gosh. Well, hopefully we remember with those negative exponent rules, you have to put it in the opposite side of the fraction. In this case, we're going to have 1 over I to the 2312th power. And that happens to also be divisible with 1 at 2312. That's 1 over I to the 4th power raised to the 578th power, which is just 1 over 1 to the 578th power, which is 1 over 1, which is just 1. So this is equal to 1. And that's our answer. So once we understand these powers of I, we can easily break stuff down in such a ways to make all the work very, very simple.